All right, guys, a river has a steady speed of 0.5 meters per second. A student swims upstream at a distance of 1 kilometer and swims back to the starting point. If the student can swim at a speed of 1.20 meters per second in still water, how long does this trip take? I encourage you to pause this video and to give this problem a shot. So let's try this. All right, you have a river that's flowing at 0.5 meters per second, and you have a guy that's trying to swim on the river. I don't know what the fuck I'm trying. Anyway, whatever. And this is traveling at a distance of 1 kilometer. All right, so the student swims upstream at a distance of 1.1 kilometer and swims back at the starting point. All right, so you can imagine that the overall speed of this guy is really just going to be 1.20 meters per second minus 0.5 meters per second over the course of whatever time it takes to swim 1 kilometer, which we can find that time. And I guess we'll call that T1. I'm not going to worry about the 1 kilometer just yet. I'm just going to kind of set this up first. So this is how long, T1 is going to be how long it takes to go from this point to 1 kilometer. And remember, folks, that X is 1 kilometer. So X is going to be 1,000 meters. And the time it takes for him to swim from this point to that point is going to be 1.20 meters per second, being carried downstream at 0.5 meters per second times T2, or I got to be careful, maybe I should call that delta T. So what's it asking for? How long does it take to make the trip? Okay, well, let's do this. And let's say that T1 is going to be 1 kilometer, 1,000 meters, divided by 1.15 meters per second. That's the difference of their speeds. And that's going to be T1. T2 is going to be the same thing, except for this is going to be 1,000 meters divided by 1.25 meters per second. All right, now since we got that out of the way, let's find the time it takes. The time it takes is going to be T equals, the total time is going to be T1 plus T2. T1 is going to be 1,000 meters divided by 0.7 meters per second. That's the difference between that speed. The T2 is going to be 1,000 meters divided by 1.75 meters per second. So that's the time it takes. So the time it takes for him to swim both streams is going to be 2016.81 seconds. Or I'm just going to write, well, it doesn't really matter. So anyways, folks, that's the time it takes. So the question is asking, compare this answer to the time interval required for the trip if it were still in water. Well, that's pretty straightforward. So I'm going to take 2,000 divided by the time, because that's the total distance it travels, regardless of the direction. It's the overall distance is 2,000 meters divided by 1.20, and that should give you the time. So the overall time comparison is 1,667 seconds. So the difference between those time intervals is going to be 350 seconds. So it's going to be 350 seconds. Anyways, folks, I hope this helps you guys. All right. So the time interval is going to be 350 seconds. Anyways, folks, I hope this helps you guys, and I hope you guys enjoyed.